Welcome to the Walton Pi. Today we're going to be going through some examples of figuring out limits at infinity. Okay, for the first example of a limit at infinity, let's look at the limit as x goes to infinity of 3x minus 4 over 2x plus 1. Let's show that that is equal to 3 halves. So what we are going to have to do is we are going to have to say that for any epsilon greater than 0, there is some big M greater than 0 such that if x is bigger than m, absolute value of 3x minus 4 over 2x plus 1 minus 3 halves has to be less than epsilon. So that is what we are going to have to be working on to try and show, and so we are going to start with this to then try and figure out what m would need to be. So if we start with 3x minus 4 over 2x plus 1 minus 3 halves, we can say that this is equal to 3x minus 4 times 2 over 2x plus 1 times 2 minus 3 times 2x plus 1 all over 2 times 2x plus 1. So that's going to give us, we have 6x minus 8 minus 6x minus 3 all over 4x plus 2. So this is equal to, let's see, we have negative 11 over 4x plus 2. So this is equal to 11 over absolute value of 4x plus 2, and this is less than epsilon. Now, as x is going towards infinity, this 4x plus 2, that is always going to be positive. So that means that we are able to take that and say that then we have 11 divided by 4x plus 2 is all less than epsilon. So 11 over epsilon is less than 4x plus 2. So we get 11 over epsilon minus 2 is less than 4x. And then divide everything by 4, we get 11 over 4 epsilon minus a half is less than x. So what we are going to do is we are going to say that this is m. However, this is going to be a little bit tricky because what we have to do is we have to make sure that m is bigger than 0. But this minus 1/2, that is what's going to be a little bit complicated. So instead of the minus 1/2, we can drop this x right here, and we can say that all of that is less than just 11 over 4 epsilon, and this we are going to make be bigger than x. So we're going to say m is equal to 11 over 4 epsilon, which is bigger than 0, because 11, 4, and epsilon are all bigger than 0. So, going back to our proof of this part, we are going to have, for any epsilon greater than 0, let m be equal to 11 over 4 epsilon, and this is bigger than 0. Then, if x is greater than m, which is equal to 11 over 4 epsilon, we have, and now we're going to just look at what is absolute value of 3x minus 4 over 2x plus 1 minus 3 over 2. Well, that's equal to what we found over here. It was 11 over the absolute value of 4x plus 2. 11 over 4x plus 2. So in your proof, you'd probably want to have those intermediate steps, but since we already did them in the scratch work, we would just copy and paste them over. So we have this, that's equal to 11 over 4x plus 2, which is where we can then say, we know x is bigger than 11 over 4 epsilon. So if we replace the 4 with the x with the 11 over 4 epsilon, we're going to have 4 times 11 over 4 epsilon plus 2. The question is, did we just increased or decreased the denominator? Which one did we do? Well, we replaced x with something smaller, so we decreased the denominator. And if you decrease the denominator, that increases the fraction. So we are going to have that. So this is equal to 11 over, let's see, this 4 and this 4 cancels. So we have 11 over epsilon plus 2. Multiply the top and bottom by epsilon. That gives us 11 epsilon over 11 plus 2. We can decrease the denominator, and that's going to increase the fraction. So that is all less than 11 epsilon over 11. We subtracted 2 from the denominator. That decreased the denominator, so it's going to increase the fraction, and this is equal to epsilon. So we have f of x minus the limit is less than epsilon. So that tells us that the limit as x goes to infinity of 3x minus 4 over 2x plus 1 is equal to 3/2. Let's go and do another example where we can actually figure out what the limit is without having to do this epsilon-M argument. So let's look at the limit as x goes to infinity of 7x to the 4th minus 13x squared plus 7 minus x to the negative 3 plus 5x to the minus 4 all over x plus x squared plus x cubed plus x to the 4th. Let's try and figure out what this limit would be. Now, this is not something we want to even attempt to try and do with epsilon-M arguments. This is just going to be too complicated. So the way that we're going to do this is we're going to look through the entire fraction to see what is the highest power of x we have. And it turns out it's x to the 4th, and it shows up in both the top and the bottom. Whatever that highest exponent is, we are going to multiply the entire top by 1 over that exponent, and the entire bottom by 1 over that exponent. So we just multiplied by 1 according to limits, and so this means that this limit is then equal to the limit as x goes to infinity of the same thing where we've evaluated that for, where we've distributed the 1 over x to the 4th everywhere through. This is going to be 7 minus 13 over x squared plus 7 over x to the 4th minus 1 over x to the 7th plus 5 over x to the 8th all over 1 plus 1 over x plus 1 over x squared plus 1 over x cubed. Now this is now a limit that we can evaluate the top and bottom. So we can break this limit up into the limit on the top and the limit on the bottom. So this is going to be equal to the limit of the top over the limit of the bottom, which is not too hard to show is going to be 7 over 1. So this limit is equal to 7. Now, this is not something we would want to try and do with the epsilon-M arguments. It is possible, but it would be complicated. But this is one way that you can be able to check these sorts of limits. Let's look at one last problem. Let's look at what is the limit as x goes to infinity of x cubed over the square root of x to the 6th plus 4. Well, this one is going to be another limit that we would probably want to look at what's the highest power of x. So we might look at this and just say, well, highest power is x to the 6th. However, it's x to the 6th inside a square root. So that's really, this is really an x to the 6th to the 1/2, or x cubed. So x cubed is our highest term. So we're going to multiply the top and bottom of this by 1 over x cubed. And so this gives us the limit as x goes to infinity of 1 over x cubed times the square root of x to the 6th plus 4. So that's the limit as x goes to infinity of 1 over the square root of 1 over x to the 6th, square root of x to the 6th plus 4. That's the limit as x goes to infinity of 1 over the square root of x to the 6th plus 4 over x to the 6th. So that's going to be the limit as x goes to infinity of 1 over the square root of 1 plus 4 over x to the 6th, and this is going to be equal to 1. So that's how we would be able to evaluate these sorts of limits, and these are the ones that we don't necessarily want to have to try and do with epsilon-M arguments, although the first example gives one way of approaching those sorts of things, but they can get fairly complicated fairly quickly. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.